Hi guys, this is integrations and area between two curves. So as you know already, area under the curve like is given by a to b integration of fx and dx. It's without calculator today, so you should know the techniques of integration without calculator. Let's take one example. You can see there is a curve negative x square over 2 plus 5, and the limit is negative 2 to 2. So simple, just integrate from -2 to 2 using power rule and then plug in the limits. So you need to substitute the upper limit first and then the lower limit. So it's very basic calculation, negative 8 over 6 plus 10 and then minus the lower limit. Negative 2 cube is negative 8 and negative 8 is positive 8. So you simplify and you get negative 16 over 6 because it is double of negative 8 plus 20, 17.4 square units. Very simple. But the focus for today is two curves. Like in this example, there is one line and there is a curve. And you can see there are two types of areas visible. One is dark yellow and one is light yellow. So of course we have to add these two total areas so that we can get the total area. And remember, this is below x-axis, and if it is below x-axis you have to reflect the curve up and then calculate the area, or just put negative in front because when you reflect it becomes negative. So the limits are same, negative 2 to 2. So the curve is x square over 2 minus 5, but as I told you it is below the x-axis, so we need to mark negative. So negative of that plus the area under the line from -2 to 2, and the equation of line is y equals to 5 because it is passing through 5. It is a horizontal line, there is no x, so 5. Or we can rewrite it in another format. Always remember upper and lower. In this way you don't need to think do you have to take negative or not. So always remember upper curve minus the lower curve. So area under the upper curve minus area under the lower curve. So -2 to 2, the upper curve is 5, the line, minus lower curve. Look, we already took negative over there and it is coming automatically here if you follow this technique, upper minus lower. You integrate it and then you plug in the values. So integration of 5 is 5x, x cube over 6 because you divide by 3 times 2 is 6 plus 5x, and then you plug in the limits -2 to 2. So this is very easy because it was a line and parabola. So remember upper minus lower. Look at this example now. So there's a brown area, so this brown area is under the parabola above x-axis, and the line there's a line, so remember that the area under the line is yellow plus brown. Okay, I'm writing the equations. Y equals to 5x is the line and the parabola is x square. So that's what we need, this area, the yellow area only. So area under the line, okay, minus area under the curve. So the line is upper curve, so we can say line 0 to 4 minus area under the curve. Okay, so you plug in the values 0 to 4, the line is 5x. Now this is not 5, okay, it's diagonal line, so it's 5 times x minus x square is the parabola. You can use parentheses, simplify, integrate and plug in the limits. Not a big deal guys, so super easy. Remember upper limit first, then the lower limit. I'm not doing the calculation for you, okay? You should practice more with these simple numbers. So that area was subtracted. Upper minus lower is the key for two functions. Okay, this is again a diagonal line kind of, and there is a parabola. The equations are parabola is negative 2x squared plus 6 and the line is 4x. So you have the thing is missing here, limits. We don't know from which value to which. Of course sometimes you can see but you can't estimate. So that's the main thing here. We don't know exactly what are the points of intersection. So that is this something extra we have to perform. So figure out what are points of intersection here, like A and B, and to find out points of intersection we need to just solve simultaneously these two equations. Negative 2x squared plus 6 equals to 4x. Just equate them because there are two common points where their x values are same. It's a simple quadratic. If you pass everything on other side, it becomes 2x squared plus 4x minus 6 equals to 0. Quadratic, of course, you can use factorization or any other method to find out what are the x values. So I'm doing the factorization, 2x minus 2 and x plus 3, because 3 times 2 is 6. So I got x equals to 1 and x equals to negative 3. So these are my limits, and from the graph we can see that. But in exam you have to make sure the limits you have to figure out from this solving the equation. So a is minus 3, b is 1. Okay, if you are still confused, so 2x minus 2 equals to 0, 2x equals to 2 and x equals to 1. Simple. Okay, now apply the limit. For integration, remember upper minus lower. So negative 3 to 1, upper curve is actually parabola, okay, minus the lower part is line. So plug in their values of y. For example, the curve is negative 2x squared plus 6 and the line is 4x. So minus 4x and then dx. Integrate, plug in the limits, super easy. The thing is point of intersections. Okay, so points of intersections are important. Okay, now let's take one trigonometric example. You can see some calculation over there if I'm doing for you, but you don't need, actually you should be able to perform these calculations. The limit is minus 3 to 1. Plug in 1 first and then subtract the values from minus 3. You can see from this GeoGebra, you can try to just confirm your answers. Okay, let's get back. So we have a trigonometric function, like the highest part is 3 sine x and the lower part is sine of 2x. So I've divided areas in 3 parts, A, B and C. So A is that area, like if you think from 0 to pi and then you subtract B, okay, and C is actually same because of symmetrical part. So we should know that the same concept from A to B, upper minus lower. And if you apply for A as 0 to pi, of course you can see that 0 to pi, the upper curve. Okay, so 0 to pi, the upper curve is 3 sine x minus, actually when you subtract, if you're subtracting for curve B, okay, the curve B is actually going down at pi over 2. So what we can do, we can divide this whole area in 2 parts if we want, and we can decide that from 0 to pi over 2 we are calculating area under upper curve minus area under the lower curve. Okay, because B area should be subtracted, but from pi over 2 to pi the area is only because of 3 sine x. And C is simple, if it depends on the question. So right now I'm doing the limit 0 to pi over 2, 3 sine x minus sine 2x, and I can add the area from pi over 2 to pi only because of 3 sine x. Okay, so because I have separated them with alphabets A, B and C, that's why I'm not counting area C here in A. And area B, if you want, you can just write area B is 0 to pi over 2 of sine 2x. Very simple. Of course, you integrate it and then plug in the values in terms of pi. You can leave your answer in terms of pi. Okay, and B and C have both equal areas because the limits are same, like 0 to pi over 2 and pi over 2 to pi. The function is same. Remember, integration of sine kx is negative cosine kx over k. Okay, so use this integration and plug in the values. Practice with two curves especially. Thank you. Bye.